Number 2, the graphs of the polar curves r equal 3 and r equal 3 minus 2 sine 2 theta are shown in the figure above for 0 to pi. A, let r be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine 2 theta. Find the area of r. So we want to find the area of the shaded region. We did a problem like this before, and since one of these r equals 3 is actually a circle, we're going to split this off into two different regions. I'm going to first of all find this area right here. So I'm going to call this area A, and I'm going to call this area B. And we are going to find each area separately. So to get the area of A, this is just a quarter of a circle, so I'm going to use 1/4 pi r squared. The radius of that circle is 3, so it's just going to be 1/4 times pi times 3 squared, and that will give me 9/4 pi. So that's the area of that one. Okay, and then to get the area of B, the area of B I can tell is bounded by the curve r equals 3 minus 2 sine 2 theta, and it starts at 0 and it ends up at pi over 2. So I'm going to be using the area of a region given in polar form. So it's going to be 1/2 times the integral from 0 to pi over 2. And then if you can just remember, it's r squared. So this is just going to be 3 minus 2 sine of 2 theta quantity squared. And when you do that, you will get an answer of, I did not write it down, so I don't know what that answer is. So anyway, you're going to get some answer for that one. And then when you add those two together, you will end up getting 9.708 as your final answer. All right, you will get 4 points for this problem. The first one, you get 1 for your limits. So if you went 0 to pi over 2, for sure you're going to get a point for that. And then you're going to get 2 points for the integrand. So I guess I'm going to kind of count it as you're going to get 1 point for this setup and 1 point for this setup. So you found one part and then you found the other part. And then my answer you get a point for. So altogether, this was worth 4 points. There is a different way that we could have set this up as well, so if you weren't thinking that that's the way that I should set it up, oh, I'm looking at the totally wrong problem, no wonder. I'm just a little confused on what we're doing. I'm looking at the AB problem, no wonder. Okay, so yes, totally different scoring, sorry about that. I was looking at the AB problem instead of the BC problem. Okay, you're going to get 1 point for the integrand. So if you have this set up right here, that's worth a point. If you have your limits 0 to pi over 2, that is worth a point. And then if you have the correct answer, that is worth a point. So this one was worth +3. Sorry about that. All right, B, for the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta at theta equals pi over 6, okay? First of all, if I want to find dx d theta, this needs to say x equals instead of r equals. So we know that x equals, if we're given a polar curve, x is equal to r cosine theta. So we know that x is equal to 3 minus 2 sine of 2 theta times cosine theta. So that's what my x equals. Notice we have x and theta. So when we ask if we need to find dx d theta, it's simply we can just use math 8 to do that. So when we want to find dx d theta, all we need to do at pi over 6 is just plug in math 8, and when you do that, you're going to get negative 2.366. You are going to get 2 points for this problem. If you found an expression in terms of x, you're going to get a point, and then if you were able to get the correct answer, you'd also get a point for that one. Okay, part C. The distance between the two curves changes for 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So it's asking me to find the rate at which the distance between the two curves is changing with respect to theta. So I'm finding the rate at which the distance is changing with respect to theta. So that's what I'm looking for. So I need to first of all figure out what that distance is. So I need a distance formula for this. If I can think of, if I want to find the distance between 2 points, and I'm actually finding it at pi over 3, pi over 3 is probably around here somewhere. Whoop. So if I just pick a point about pi over 3, what I'm trying to do is find the distance between those 2 points. And to find the distance, it's just going to be this point minus this point. So this point is given by 3, and then minus the other point would be on the other curve, so it's going to be minus 3 minus 2 sine 2 theta. Okay, so that's the formula for distance. So if I want to find the derivative of distance, all I need to do once again is just use my Math 8 button, and we're going to be finding it at pi over 3. So if I use Math 8, we should get negative 2 as our answer. So then that is it. We are going to get, let's see, 1 point for finding a formula for the distance, and then we'll get 1 point for getting the derivative. Okay, part D. A particle is moving along the curve r equals 3 minus 2 sine 2 theta, so that d theta dt equals 3 for all times t is greater than or equal to 0. Find the value of dr dt at theta equals pi over 6. Okay, so this one, notice we want to find d theta dt, so all of a sudden we've turned into a related rates problem because we want to find the derivative with respect to time. So if I want to find the derivative of this, we're going to have dr dt is equal to the derivative of this one, so it's going to be the derivative of that curve, which is going to be negative 4 sine 2 theta, but then don't forget, and I did incorporate the chain rule a little bit there because of the 2 theta, but then don't forget that we do have to take this with respect to time, so it's going to be d theta dt. Okay? So now if we just plug things in, if I want to find dr dt, it's just going to be negative 4 sine of 2 theta. Well, this is 2 times pi over 6, and then times d theta dt. Well, we know that d theta dt is equal to 3. So if I find that answer, that will equal, this will be negative, my final answer will just be negative 6, I believe. Okay, so what we're going to do, and I could have, instead of actually finding this, I could have found just dr d theta using my Math 9 button, and then I'd have to still multiply it by d theta dt, which was 3. So just another option for that. This was worth 1 point. First of all, I did have to use the chain rule. I had to include the d theta dt. So if you included the d theta dt when you were taking the derivative, you get a point, and then if you get the correct answer, you also get a point.